All fuses have three basic ratings that must be understood and are crucial to specifying and applying the correct circuit protection. These are voltage, current or amp rating, and interrupting rating. Proper application requires the overcurrent protected device's voltage rating be equal to or greater than the system voltage. When an overcurrent protected device is applied beyond its voltage rating, there may not be an initial indication that anything is wrong. But when it attempts to interrupt an overcurrent, adverse consequences can result and may self-destruct in an unsafe manner. There are two overcurrent protected device voltage rating types, straight voltage rated and slash voltage rated. A straight voltage rated device can be installed in any electrical system regardless of the grounding system. All fuses are straight voltage rated and their proper application is straightforward. These devices have been evaluated for proper performance with full phase-to-phase voltage. The fuse's voltage rating must be at least equal to or greater than the circuit voltage. For example, a 600 volt rated fuse can be used in a 208 volt circuit, but a 250 volt rated fuse cannot be used in a 480 volt circuit. Most low voltage power distribution fuses have 250 volt or 600 volt ratings. Bussmann series low peak LPJ fuses are rated at 600 volts and can be used on any system 600 volts or less, whether it's solidly grounded, ungrounded, impedance grounded, or corner grounded delta. A straight rated fuse or circuit breaker can be used to protect single-phase line to neutral loads when supplied from a three-phase solidly grounded circuit. For example, a 300 volt rated fuse can be used to protect single-phase line to neutral loads when supplied from a three-phase solidly grounded 480-277 volt circuit, where the single-phase line to neutral voltage is 277 volts. This is allowed in this application because a 300 volt fuse will not have to interrupt a voltage greater than its 300 volt rating. Slash voltage rated overcurrent protected devices have limitations imposed upon them that straight rated voltage overcurrent protected devices do not. Multiple pole mechanical overcurrent protected devices with a slash voltage rating, such as circuit breakers, self-protected starters, and manual motor controllers, are limited in their application and require extra evaluation for use. The slash rating can be broken down into its higher and lower numbers. The lower rating pertains to overcurrents at line to ground voltages, intended to be cleared by one pole of the device. The higher rating number pertains to overcurrents at line-to-line voltage, intended to be cleared by 2 or 3 poles of the device. The proper slash-rated circuit breaker application is such that the line-to-ground voltage does not exceed the device's lower voltage rating, and the line-to-line voltage between any two conductors does not exceed the device's higher voltage rating. Understanding the higher and lower ratings is important, as slash-rated devices misapplication can result in it being applied outside its voltage rating with dire consequences should the device be called upon to interrupt overcurrents. The amp rating of the overcurrent protected device indicates the amount of current that can flow through the device without causing it to open. In many cases, the fuses are sized per NEC requirements, and the next standard size must be used per NEC section 240.6. In selecting the amp rating, consideration must be given to the load type and code requirements. The fuse amp rating normally should not exceed the circuit's conductor current carrying capacity that's determined by ampacity adjustment factors covering how and where it's routed or other NEC-related areas. For the most part, if a conductor's current carrying capacity is 20 amps, a 20 amp fuse is the largest it should be used to protect it. There are specific circumstances in which the amp rating is permitted to be greater than the circuit's current carrying capacity, such as in motor circuits. Dual element time delay fuses are permitted to be sized up to 175% and non-time delay fuses up to 300% of the motor's full load current. As a rule, the fuse amp rating should be selected at no closer than 125% of the continuous motor load current. There are exceptions, such as when the fuse switch combination is approved for continuous operation at 100% of its rating. The third, and arguably the most critical, if not most misunderstood rating, is the interrupting rating. Overcurrent protected devices must be able to safely interrupt destructive fault current energy. If a fault current exceeds a level beyond the device's capability, it may rupture, causing damage and posing a serious safety hazard. The rating that defines the overcurrent protected device's ability to maintain its integrity is called its interrupting rating. It's important when applying a fuse or circuit breaker to use one that can safely interrupt the largest potential fault currents. Most modern current limiting fuses have a 200 kA or 300 kA interrupting rating and can be used in just about any system without fear of misapplication. The National Electrical Code in Section 110.9 requires equipment intended to break current at fault levels to have an interrupting rating sufficient for the available fault current. The fuse interrupting rating is not dependent on a particular voltage when applied within its rating. For example, a 600 volt rated LPJ fuse has a UL listed 300 kA interrupting rating for any voltage up to 600 volt AC. Whether for the initial installation or system updates, a fusible system can maintain a sufficient interrupting rating throughout its life. There is little need for additional fault current calculation or worry that the fuse will be misapplied due to an improper interrupting rating. Nor is a short circuit study needed when applying Bussmann series dual element time delay low peak fuses for selective coordination, so meeting NEC requirements is easy. Additionally, high interrupting ratings help equipment achieve a high short circuit current rating that may be limited by a device with a low interrupting rating. When applying a fuse or a circuit breaker, the device must be able to safely interrupt the largest available fault currents at its aligned terminals. The following test shots will demonstrate the destructive nature of short circuit events and the importance of proper interrupting rating. These tests will be conducted on a 480 volt circuit with an available fault current of 50,000 amps. It is not the intent to degrade any equipment, but rather show the possible result of misapplication of the equipment used. The first test will show two 600 volt general purpose fuses with a 10,000 amp interrupting rating. A short circuit is applied directly on the load side of the fuses. Notice the large destructive forces released during the test. This presents a serious safety hazard and misapplication. The next test shows a higher rated circuit breaker on the same test circuit with a short circuit directly on the load side of the two-pole device. In this case, the circuit breaker is listed to interrupt 14,000 amps. Again, notice the extreme thermal and magnetic force of this event. Molten metal and shrapnel pose serious safety hazards to electricians, maintenance personnel, and anyone that may be nearby. The final test is not as exciting, but it is very important to demonstrate the proper application of overcurrent protected devices when it pertains to interrupting fault current. Again, the test circuit is the same, capable of delivering 50,000 amps of fault current, but in this case, the fuses protecting the circuit are Bussmann series low peak dual element time delay LPJ fuses with a 300,000 amp interrupting rating. Notice how the fault was cleared safely and without violence. As depicted in these tests, it is absolutely necessary to determine the available fault current at the line side terminals of each overcurrent protected device. The advantage of high 200 kA or 300 kA fuse interrupting ratings is that they can be applied and used to eliminate the need for fault current calculations, as these high interrupting ratings will exceed the available fault currents for virtually all power distribution systems. Eaton's Bussmann series low peak fuses are the only fuses tested and listed by UL to 300,000 amps. This high interrupting rating is capable of safely interrupting virtually any available fault current encountered in a 600 volt or less system. The 300 kA interrupting rating provides assurance that when a properly sized low peak fuse is installed, the system is covered for the worst case overcurrent event.